Yes, welcome back to the session. In this video, I'm going to discuss about angle of repose. Okay, so look at the first diagram here. So this is the object of mass m which is placed on the horizontal surface. If there is no external force is acting on this body, then the object is at rest state because the total weight of this object is acting vertically downward direction. This weight is balanced by the normal reaction force exactly opposite direction. So this normal reaction R is balancing the weight of the object, so the object is at rest state. Okay, so this is the situation. Suppose, so initially this is the flat surface, right? That is the reason if there is no external force, the object is not at all moving. Suppose the flat surface, if we increase the angle, maybe that angle is 20 degree or 30 degree or 40 degree, whatever it is, then if you are increasing this angle of inclination, then what will happen? At a particular angle, maybe at 35 degree or 40 degree, at a particular angle, whatever the body which is placed on the horizontal surface, it is automatically slide down, right? So look at the second case here. So I'm increasing some angle of inclination here. Let's assume theta. Maybe the value is 30 degree or 35 degree, whatever it is. Whatever the object here placed, this object for this small angle of inclination, the body ready to slide down in this direction. Okay, so whatever the location, the total weight of this body was acting vertically downward direction only, right? There is no doubt in this. And normal reaction force also acting in this direction. So the normal reaction always perpendicular to this plane surface. Okay, now if we extend this normal reaction in backward direction, it makes an angle theta with respect to mg. That is the reason this component is mg cos theta. Okay, if this is mg cos theta means exactly perpendicular component is this one. So this one is mg sin theta. Okay, so whenever a body is sliding over the inclined plane like this, then definitely there must be a frictional force which is acting in backward direction. So that friction I am taking Fs. Okay, so according to the friction concept, when an object is sliding means opposite side, in between the object as well as contact, there must be one more force is developed. That force is called frictional force. Okay, so look at the diagram carefully here. The normal reaction N, which is balanced by the mg cos theta, right? So we can write it as N is equal to mg cos theta. Let us assume this is equation number 1. Similarly, whatever the friction was developed here, Fs, this friction is balanced by the mg sin theta in opposite side, right? So Fs is equal to mg sin theta. So let us assume this is equation number 2. So after getting this equation 1 and 2, I am dividing 2 by 1. So equation 2 means Fs, equation 1 means N. So Fs formula we know, mg sin theta divided by normal reaction means mg cos theta. Therefore, numerator mg, denominator mg cut. The rest of the equation Fs by N is equal to sin theta by cos theta. This term is called tan theta, right? So according to friction, Fs by N is called mu. That means a coefficient of friction. So mu is equal to tan theta. From this, theta is equal to tan inverse of mu. So this is the expression for angle of repose. Okay, so I told you already, whenever an object is placed on the horizontal surface, if there is no force means the object is at rest state. But if we increase this flat surface with some angle like this, at a particular angle, the body, whatever the object was placed here, this object automatically slide down, even though if you're not applying any external force. That moment is called angle of repose. So let's see the definition here. The minimum angle of inclination So here this is the angle of inclination, theta, right? The minimum angle of inclination with which a body ready to slide down on inclined plane. Okay,